The presentation on complex numbers by Narwanis Mathema. A complete guide for the students of first year and intermediate class by B.M. Narwani. Introduction of complex numbers. Complex numbers are an extension of real numbers. They allow us to work with square roots of negative numbers. Used in mathematics, physics, and engineering. The basic unit is iota, where iota square is equal to -1. History of complex numbers. In 1545 Cardano used square root -1 in equations. In 1572 Bombelli defined operations on complex numbers. In 1637 Descartes called them imaginary. In 1700s, Euler and de Moivre expanded the theory. In 1806 Argand introduced geometric representation. In 1800s, Gauss formalized and accepted complex numbers. Applications of complex numbers. Electrical engineering, alternating current circuits, signal processing, waves, frequencies, quantum mechanics, wave functions, mathematics, roots of equations, transformations, control systems and robotics, daily life uses of complex numbers, electric circuits, used to measure AC current and voltage. Signal processing, helps in analyzing sound, radio and mobile signals. Computer graphics, used in animation, games and image rotation. Wave motion, models vibrations, light and sound waves. Engineering calculations, for stress, force and flow in machines. Quantum physics, describes particles at atomic level. Definition of complex numbers. A complex number is written as Z is equal to A plus B iota or the ordered pair A comma B. Where A is the real part, B is the imaginary part and iota is the imaginary unit where iota is equal to square root -1. Example, Z is equal to ordered pair 3, 2 or 3 plus 2 iota. Types of complex numbers. Number 1. Real numbers 0, 2, -3, 2 upon 3, under root 5 and so on. Number 2. Imaginary numbers 2 iota, -3 iota, iota under root 5 and so on. Number 3. Complex numbers 3 plus 2 iota, 7 -3 iota, 8 plus iota under root 5 and so on.
Basic operation on complex numbers. Equality. A, B, equals, C, D, if and only if A equals C and B equals D. Addition. A, B, plus, C, D, equals, A plus C, B plus D. Subtraction. A, B, minus, C, D, equals, A minus C, B minus D. Multiplication. A, B, multiply, C, D, equals, AC minus BD, BC plus AD. Division. A, B, divide, C, D, equals AC plus BD upon C square plus D square, BC minus AD upon C square plus D square.
Conjugate of complex numbers. If Z is equals to A plus iota B, then complex conjugate of Z, denoted by Z bar, is defined by Z bar is equals to A minus B iota is equals to A minus B. Examples, the conjugate of 3 plus 2 iota is 3 minus 2 iota. The conjugate of 6 minus 5 iota is 6 plus 5 iota. Uses, to simplify denominator. Modulus or absolute value of complex numbers. If Z is equals to A plus iota B, then modulus of complex number is denoted by mod of Z and is defined as under root A square plus B square. Example, the modulus of 3 plus 4 iota is 5. Uses, distance from the origin, length of the vector, magnitude of voltage or current. Argand diagram of complex numbers. The Argand diagram, a way to represent complex numbers graphically, a complex plane where x-axis, real part, y-axis, imaginary part. Each complex number is a point or vector. For example, 2 plus 3 iota is plotted as ordered pair, 2, 3, in first quadrant. Properties of complex numbers. Commutative property of addition, commutative property of multiplication, associative property of addition, associative property of multiplication, distributive property of multiplication over addition. Additive identity, 0, 0, additive identity, 1, 0, additive inverse, minus Z is equals to minus A, minus B. Additive inverse, Z inverse is equals to A upon A square plus B square, minus B upon A square plus B square, and triangular inequality. Properties of imaginary unit iota. Powers of iota repeats every 4 steps. Divide the power of iota by 4, then iota power n is equals 2. If remainder is 0, then answer will be 1. If remainder is 1, then answer will be iota. If remainder is 2, then answer will be minus 1. If remainder is 3, then answer will be minus iota. 1, minus 1, iota and minus iota are the fourth roots of unity, and 1, omega, omega square are the cube roots of unity, where omega is a complex number. Thank you so much for watching this video. If you like this video, then subscribe my channel and share this video with your friends.